This is sample problem 1. Its 3,000 gram solution contains 1.5 grams of dissolved sodium chloride salt. What is the concentration of this solution in parts per million? The equation is given below, which is found on table T.
We have 3,000 grams of solution. We have 1.5 grams of the salt. And we want to know what is the concentration in parts per million. So that's the important part that we want. We're going to write the equation like we always do. We're going to write the mass of solute over the mass of solution times 1 million. Okay, so what do we have? Well, we're looking for the parts per million, so we can leave it as PPM. We have the mass of the solute, that's the 1.5 grams of sodium chloride. We have the mass of the solution, that's 3,000 grams. And then we're going to multiply that by 1 million. There we go. Okay. So now we're going to punch in the numbers. And when you solve, you end up with PPM equals 500 parts per million. However, none of the answers look exactly like 500. So we're just going to convert that to scientific notation. Since we have 2 zeros, that's going to be 10 to the second power. So we have 5 times 10 to the second power, which is equal to 500. So it's 5 times 10 to the second power parts per million. And that's sample 1.
Sample problem 2. What is the total mass of solute in 1,000 grams of a solution having a concentration of 5 parts per million?
Look at sample problem number 2. What is the total mass of a solute in 1,000 grams of a solution having a concentration of 5 parts per million? Again, we wanted to see what's important. We want the mass of the solute. So that's going to be our X. We have 1,000 grams of solution this time. And we have a concentration of 5 parts per million. We're actually given that information. So we go to our equation first. PPM equals the mass of the solute divided by the mass of the solution times 1 million. We're going to put in our numbers. Our parts per million is 5. Our mass of the solute is X. The mass of the solution is 1,000. And then we have 10 to the 6th power. That's going to be our million. We want to get X to be alone, so I'm going to divide both sides by 10 to the 6th power. We're going to simplify it, and we end up with 5, let me fix that, over a million equals X over 1,000. So now you can cross multiply and solve for X. It's much easier this way when you get rid of that million on this side over here. And you're left with X equals 0.005, which in this case, if you look at the sample problem, that is answer number 1. Now, you're asked to do 2 homework problems. So, on the following slides, there are 2 homework problems. directions, so read the directions. And then bring solved problems with work to class on Monday, and that is March 18th. Good luck.
This is what you're asked to do for the homework problems. Copy the questions below. Solve both problems. Show all work. Bring solved problems to class. Even though it has multiple choice, I do want you to show all the work. Homework problem number 1. Please copy this down. Make sure you show all work. Now, going through this, what is the concentration in parts per million? So you're looking for parts per million of a solution containing 333 grams of sodium nitrate, which is NaNO3, in a 700 grams of water. Notice they don't give you the grams of solution, so you're going to have to add up the grams of the solute, which is the sodium nitrate, with the grams of the water to give you the grams of solution. So keep that in mind when you're solving. The second question, problem number 2, a little bit more straightforward. How many grams of sodium chloride are needed to be dissolved in water to make 2,000 grams of a 100 parts per million solution?